Assalamualaikum. My name is Muhammad Syuib bin Yunus with metric number MA25064. So today I want to present my part. So the first part is what is miling? So miling is a machine process that removes material from a workpiece using a rotating cutter tool to produce the desired shape, size, and surface finish. So on milling machine, there are four operations. For the first operation, which is spacing, which is to reduce the length of the workpiece. The second operation that will apply on this milling machine, which is slot milling. It is to cut a slot into a workpiece using an end mill cutter. The third step, which is drilling. So a drilling is a process that used to create holes in a workpiece. And the last part, which is counterburing, which is a machining operation used to make the hole little longer, little larger. So these are the tools that we use on milling machine. So we have end mill cutter, which is to cut and shape the material. We also have vernier caliper, which is to measure the length, height, and depth of a piece. We also have the drill bit that we'll use on drilling step, which is to produce holes in the workpiece. Other than that, on milling operation, we also use the counter bore drill bit, which is to make a hole with a flat bottom and larger diameter on top. So before we started on drilling process, we use this tool, which is center drill bit, which is to make the drilling starting point. So as you can see, we also have the C-type press spanner, which is to tighten and loosen the collet chuck nut when installing or removing cutting tools. We also have the collet chuck, which is to hold and center a cutting tool during machining operation. This is the vertical milling machine which is the main machine that used in our laboratory operation, such as pressing, slot milling, drilling, and counterboring. So it is a type of machine that removes material from the workpiece using a rotating cutting tool to produce the required shape and dimension.
Assalamualaikum. My name is Muhammad Khairil bin Abdul Muhaimin. My matrix number is MA25063, and in this process plan, I will be explaining to you of the method that we use and how we execute it in the lab. So the first one is to measure the workpiece using vernier caliper. This is to get the initial measurement of the workpiece. The second step is facing. Facing is to remove any extra material of the workpiece using a face milling cutter. The third step is step milling, which is using two flute and mill 16 mm diameter to lower the height of the workpiece. The next step is slot milling, which is uh, to make a slot using two flute and mill 8 mm diameter. Then central drill is used to basically make a small hole, because later on when we use an actual drill tool, it doesn't wander off because of slipping. Then the last step is counter boring. We use counter bore 10 diameter to enlarge the current hole. Next, we go to the machine setup. This is where all the process will be begin, but we need to make sure that this machine is already set up first before we do any of the process of this lab. So the first one is to make sure that the machine switch button was turned on. Second, the lamp was turned on to ensure that the process could be observed clearly. This is totally optional. Then the third, a suitable fluid end mill was inserted into the collet chuck at half of its body to ensure stable rotation. Fourth, the end mill cutting tool is then slotted into the spindle and tightened with a handle. Next is the speed of the machine was adjusted to 800 rpm. Then lastly, the direction of rotation of the spindle was observed before the milling process began. Alright, this is the first step of this whole lab, which is facing process. how to do it, we must make sure that the workpiece was attached to the milling machine table using clamp to prevent it from slipping. Then the face milling cutter was mounted on the spindle of the machine. Then the third step is the feed rate and spindle speed were adjusted to 800 rpm to prevent the workpiece to get damaged. The spindle speed is actually depends on how large of your workpiece is. So every workpiece have a different spindle speed and feed rate. Then the first step is the cutting tool must be rotated at a clockwise rotation. And lastly, after the facing process finish, we must measure the workpiece so we get the desired measurement that we want. Okay, now we have to do a step milling, which is basically a process where we want to remove and lower the height of the workpiece. Then the first step is to make sure that the workpiece was attached to the milling machine using clamp to prevent it from slipping. Then here we have to use a two fluid and mill 16 mm diameter and mounted on the spindle of the machine. Then the workpiece was placed perpendicularly to the axis of the cutter to ensure that the cutting process is right. Also, we must make sure that the cutting tool is rotating at a clockwise rotation. Then the workpiece was fed into the cutting tool until it reached a specific depth of 4 mm. Then lastly, we must measure the workpiece using a vernier caliper so we can get the desired measurement that we want. Okay, after those two process is finished, we must proceed with the slot milling. So again, we must attach the workpiece to the milling machine table using clamp to prevent it from slipping. Then this time using two fluid and mill 8 mm diameter was mounted on the spindle of the machine. Then the cutting tool was adjusted to the starting point of the slot of the workpiece. Uh, the same spindle speed were used. And lastly, the milling process began by turning the cutting tool at clockwise rotation until the cutting tool reached a specific depth. Okay, now we come to the last process, which is the center drilling, and counter boring. So, how we execute it? Again, we must attach the workpiece to the table using clamp to prevent it from slipping. Then, this is where center drilling is used. We must mark uh, the center of two holes on the workpiece. Then, a center drill was mounted on the spindle of the machine and was used to create a small dent to ensure that when we use an actual drill, it does not wandering when it makes contact with the workpiece surface. Then, after the center drilling phase is finished, the two holes were drilled using 8 mm drill diameter. Then lastly, the counterbore 10 mm was used to enlarge the hole, and the speed for the machine is at 400 rpm.
Before we do milling, we might have to consider a few precautions. Firstly, we have to make sure the workpiece is secured tightly with vice. And for further validation, we have to tap it with rubber hammer and make sure the workpiece does not move. Secondly, we must match the correct spindle speed to the material bin machine so we can have a better surface finish. Thirdly, we have to verify the cutter rotates in correct orientation relative to the feet to avoid climb milling prep or most likely known as the workpiece shifted from its original state. Fourthly, we have to always stop the spindle completely before measuring, adjusting, or cleaning the workplace to avoid incident like your clothes get tangled uh, in the machine. Before we operate the milling machine, firstly we have to follow a few safety rules. Firstly, we have to wear safety glasses. This is mandatory because it is to avoid metal debris and dust going into the eye, causing eye injuries and vision impairment. Secondly, we have to wear safety shoes to protect the wearer's foot and ankle from workplace hazard while providing physical stability and comfort. While we're handling the machine part or the workpiece, accident can always happen, and the workpiece can fall on our feet and causes injury. This is to prevent that. And lastly, we have to wear workshop jacket. This is to protect the upper body and arm from mechanical scrapes, hot sparks, and fluid splashes. When we operate the machine, we can always be exposed to the uh, machine head, to the cutting head, and can easily get scraped by it.
Hello everyone, my name is Sharifah Narisha Adila binti Said Nasir, MA25059. This slide presents the finished workpiece after all machining operations were completed. The top view shows the slot machined on the upper surface, while the front and side view clearly illustrate the steppered profile and overall geometry of the component. The required features, including the slot, drilling holes, and counterbore, were successfully produced according to the engineering drawing. Overall, the workpiece achieved the intended shape and dimension, demonstrating the successful application of face milling, step milling, slotting, drilling, and counterboring operation. However, minor surface scratches and tool marks can still be observed on some machined surface, indicating areas for improvement in surface finish quality. For this slide, after machining was completed, dimensional inspection was carried out using the vernier calipers. The measured dimensions were compared with the dimensions specified in the engineering drawing. The result shows small deviation in the overall length, width, and height of the workpiece. However, important features such as the step height, slope depth, and counterbore diameter made the required dimension. Overall, the machining process was successful and produced a workpiece that closely matched the design specification. During the machining process, several problems were encountered, including stretch on the workpiece surface, burr formation at the edges, and slight dimensional errors. These issues were mainly caused by the presence of aluminum chips during milling, tool misalignment, excessive material removal during the finishing process, and measurement mistake during setup. To overcome this problem, coolant should be used more effectively to remove chips and reduce heat generation. In addition, the finishing depth of cut should be reduced. The datum and machine should be rechecked before machining, and the bearing should be performed after each operation to improve the surface finish and dimensional accuracy of the workpiece.
As a conclusion, we have successfully mapped and structured sequential manufacturing process plan from raw mild steel to a finished engineering component. We are able to demonstrate precise integration of foundational machining operation, including facing, milling, drilling, counterboring, slotting, and also step milling. We are able to ensure drawing compliance and dimensional precision by applying systematic inspection technique and high resolution metrology tools.